Right, so now we come to the demo of the plugin, and to demo this plugin I have opened a 3D plus time dataset that ships with Vollseg as the samples. And here in the plugin you can see that you have possibilities of combining these different models to actually get the segmentation. And if you choose a StarDist model for doing the segmentation, you have all of these StarDist options which are shown over here. However, if you did not have a StarDist model, you would have some of these options actually disappear, and only the options like styling, which we still need for the segmentation, would remain in this particular tab. All of these advanced options appear as tabs, and then you have to choose a combination of your model. For example, let's say if I choose a 3D unit model with a 3D StarDist model, and then I go to the Vollseg parameter selection, I would see that some of the options are chosen for me by default. For example, it's by default going to use the probability map for doing the watershed. It's going to use a unit to create the binary mask, and it's going to do the seed pooling, as is the case for doing segmentation in the Vollseg setting. However, if I did not have a unit model, it would make this option disappear. And if I use a customized K model, now I'm actually going to use a denoising model to get the semantic segmentation instead of a unit model to get the semantic segmentation. And if my choices were not valid, that is, if I was combining a 3D model with a 2D model, I would not actually have this run button available. For example, let's see what happens if I actually give it a StarDist 2D model instead of a StarDist 3D model. So here, and now you can see that the run button has disappeared, and this is showing you why it's actually an invalid choice. So you have to go and make a proper choice where you choose the StarDist model, which for this case is for the carcinoma cells, and then if you don't have to change any other option, you can hit run and the computation will start. And now here I built another option. For example, let's say you start the computation, but then you forget, okay, my GPU requires more tiling, and just not tiling it is not going to work for my particular image on my particular computer. So for this, you can actually interrupt a running time-lapse calculation, because the time-lapse calculation is running in the background thread, and once it goes to the next time point, it's going to actually interrupt this calculation. So you can change whatever parameter was not working for you, and then you can restart this running calculation, and it would start the process again from the very start. Now there's another option that you are going to get a lot of these displays as a result. So you're going to get the probability maps, the unit results, the StarDist results, the denoising results, right? But if you don't want to see any of those results, you can actually deselect it over here, and then you are not going to see them appear on the left panel at the end of the computation. If you don't want to see these advanced parameters, you don't have to go over to these panels to do anything, and by default you would actually just see this if you have chosen the StarDist option, or if you have chosen no StarDist option, you would even see less options. So user can have simplistic choice to make of the model combinations only to get the results for their particular data set. Okay, now once the calculation is over, you will see all of these results on top of your original image. For example, you will see the denoised image, and then what you are interested here is probably just to see the results of the segmentation. So I'm going to hide all of these results, and maybe here I cannot actually see this in the 3D view, so I'm just gonna do this in the 2D plus time view, right? So you have this Z, and you have these segmentation labels which are coming now from Vollseg, and if you zoom in to see some of these labels, you can see how the segmentation quality actually went for this 3D plus time dataset. And this is particularly the case for these irregularly shaped cells, that you would need something like this. And for this particular case, if you want to see the StarDist results, you can just toggle the visibility of StarDist, and you can see the star convex approximation for the segmentation of these cells. And for the comparison, you can actually also just see how Vollseg compares for this segmentation of these cells, right? And that's one example for the carcinoma data set. And then let's go to another example. Now this example is also available from the Vollseg samples, and it's embryo cells of Ascadian. And for this particular case, you actually don't have to use any combination of models, you just have to use a customized UNet model for this particular case. So for this case, it's a singleton model doing the job for you. If you have to adjust the tiles, you can adjust the tiles, otherwise you don't have to. And depending upon your GPU, you may have to adjust the tiles or not, right? So in this case, I'm just going to run it with this setting, and this is the example where you can actually have a singleton model which is going to give you the results. And Vollseg allows you for either having a combination of these different models for giving you the results, or singleton model giving you the results. For example, if you just have a denoising model and you denoise the image, it's going to actually give you a semantic segmentation which comes out of just threshold Otsu of the denoised image as a result along with the denoised image. Or you have a combination of these different models for giving you these results. And in the next example after this, I'm going to show you another combination where I used a StarDist model with a region of interest model, where you can actually have a 3D StarDist model with a 2D region of interest model actually working together well to giving you the segmentation for your particular cells. And here these are the two results that you get. One is the instant segmentation for each of these cells, and then you can see that other than the instant segmentation, if you turn off this visibility, you would see that these are also giving you the skeletons of where the membranes are. And depending upon what your workflow requirement is, you can actually use this membrane results, which are these, or you can actually use the semantic segmentation results, which are actually these. So that's for these two data sets. And now let's move over to another interesting data set.